Alright guys, this is Mr. JP on the beats. Let's trouble you small with let's trouble you understanding with this. Understanding some mathematical terms. See, a lot of people don't know, even if they are looking at this, it's simple. What do you want to say? Now look at this. Collect like terms has failed a lot of students. Many of them. You understand? There are many reasons why we collect like terms. You understand? Many of them, in fact, some SST don't even know why we collect like terms. Even if they grow up with it, collect like terms. But when it comes to SS, maybe your past question, they didn't really know why we collect like terms. How do we collect like anyway, let me ask you, yes. Why do we collect like terms?
We collect like terms to get a definite answer.
To get a definite answer.
Yes.
No. let me teach you. Now, collect like terms came from this. Like. What's not like? The same. Now check this. When you have something like this, 2 plus 2a equals to 3 minus 4a. No, something like this. We collect like terms because they are different and they cannot add. What is this? If you have something like this showing the state of a is doubled. So a is twice, is 2, but in addition. But if we have a squared, is also in two states, but in multiplication. So anytime something is up, is in multiplication, but it's showing how they are. So how many is a? 2. You understand? But if it's down like this, it's showing its state, but in addition. So for example, if I want to get this, I'll say a plus a. I just added. If I want to get this, I'll say a times a. Very good. Now let's see. So let's see now. So this is a constant, of course. A constant is a number that don't have alphabets within it. You understand? Like all the alphabets, A, B, C, D, E, F, G, H, I, J is called unknown. We use it in maths a lot. It's called unknown. Good. Unknown means we don't know it. So for example, if you have something like this, 2 plus a equals to 3. Find a. You see it now. It's supposed to be, they're telling you that I'm supposed to write something here. What will give me 3 if being added with 2 is 1? That's a part of understanding you need to. So if you understand that, okay, that this one and this one, they are the same, but just I need to find what is missing. So we can use alphabets for that, to represent anything. We can use A, B, C, anything, P, X, or so. So this is an unknown. This is an unknown. They're telling that the unknown they're looking for is twice. If we plus those two and then add with it, these two must be balanced. Now let's see. So when you have something like this is a constant. This is not a constant. So when you are adding a constant with a variable, it cannot go because why? They are not exactly the same. So it must be exactly the same. This is how I teach my students. This can go, but what's called it? This. So that is the reason why we now collect like terms. Go and meet your friend that looks the same. So when this one is going like this, you will now say 2 and then bring this. This and this, they are constant. You join them. So here there's plus here, but we're not seeing it. When you come like this, you come what? Minus 3 equals to, here is already minus 4a. Then here is what? Plus 2a. When you come like this, you come what? Minus 2a. Now check. This one can go because it's just number. This one, the same. It must be the same letter. So you now say, okay, we have now connect like this. You see these two now. And sometimes if you are solving, for example, you are solving 2 plus 3b squared, a plus 3b squared minus 2 equals to 5b cubed minus 2a. We can also collect like terms. Now check this. Which one is alike? Which one do you feel that is alike? If you check this, a, you see it. But this one has 2, this one don't have. I told you that a is what? It's showing the state. You see, 1. Here is showing the state, but there's nothing here. This one is showing how many is a? 1. So I now know, okay, let me correct them. I now put the state, I explain its state is 1. You understand? So here is 1a. So and here is what? 2a. So when it comes like this, it become what? Minus plus what? 2 what? A. So you don't say that they are not the same. I just collected like terms. You see, others are not alike. How? Check this. I cannot say, let me say one. Okay, this one, let's say it can go. They are different, and also this attack it. So because they are different, I will not. They are not alike. You understand? So how much more this? Only these two cannot even minus, because this one has spoiled it and this one has also spoiled it. So this one cannot even go with this, and it cannot even go with this. So it's only this that should come. The rest should be casted out. How? Let's see. 5b this. Here is plus. Now go like this, minus 3b squared. Then this one plus what? Plus 2. So it's only this one that is alike, that is alike. Then this one is so different. All of them is so different. So what are we going to do? Just leave it like that. You understand? So this is the mystery behind collect like terms. So I cannot do anything here because they are not alike. I will leave it like that. So if I ask you what is a plus 2, what's a plus 2? A plus 2 is what? It cannot go. The state of a is 1. This one is not an algebra. It's not even alike at all. So you just repeat it. A plus 2. This is the answer. They are showing this thing means, anyway, I'm coming to this. You see, this equation came from Latin word equatus, which means what? Equal sign. So if I say 1 plus 1 equals to 2, I'm saying that the left hand side is the same with the what? Right hand side, the result in the right hand side. So if I say 1 plus 1 is equals to 2, I'm saying they are the same. But if I claim here, I'm not saying x, I'm not saying now find x. I'm saying that you must find something. When you are solving, you must find the value of x that at the end, when you plus it, you must get 2. That's why so many people fail their exam. They don't check the exam, the answer to the question. You know, for example, if they give me something like this now, and they say A 1, B 2, C 3, they give me something like this, and you just come, maybe you make mistakes somewhere or something, maybe because you are human, you just say now can have minus 2. If you put, let's say they give you A 1, B 2, C 3, D minus 2, and maybe you mistakenly, or let's say minus 1. Now, mistakenly, you gotta choose here, and you maybe as you are solving, instead of to write 1, you wrote minus 1. Now, you will not say, okay, let me check it before going to number 2, if you have time. So, you will not say, okay, 1 plus, so whenever I have x minus 1, will it give me 2? Because these two must be equal. That's the meaning of equation. Equation came from that word equatus, which means equal sign. They must be equal to. So the left hand side must be exactly the same answer with the right hand side. Now check this. So if you have 1, now plus times minus is what? Minus. I'm even come to that. So 1 minus 1 is what? 0. It didn't give 0. So this is not your answer. So that's why some people will now say, the devil is after me. Because you didn't check it before you move from that seat. Now check this. So let's solve this. When you have something like this, of course, you see, collect like terms. You know why? You cannot plus them. Wow. So I have to go and collect the ones I can plus. So you now say, okay, then let s stay, right? Then this is what? 2 minus 1. X is equal to what? 1. So which means I'm not showing that s is 1. This thing means the result. So s is 1. 1 is x. X is 1. So I'll not say, okay, let's test it. Let's prove. 1 plus, if I put the result 1, will it give me 2? Yes. So I'm not saying, okay, my answer is what? 1. So that's the result. That's the secret of equation.